More than 100 million gallons of water would soon flood the dock. Thousands of workers stood by. Engineers monitored stability calculations down to the smallest detail. And slowly, one of the most powerful warships ever built would begin floating again. Right now, other carriers, like the USS Ronald Reagan, are undergoing the exact same transformation. Behind the scenes, inside some of the largest shipyards in America, a hidden army of welders, riggers, engineers, nuclear specialists, and shipbuilders are working around the clock to keep the U.S. Navy alive. Because aircraft carriers are not just ships, they are mobile air bases, floating military cities, symbols of global power projection. And maintaining them is one of the most complicated engineering operations on Earth. Tonight, we are taking you inside the massive dry docks where America's supercarriers are rebuilt from the ground up. From the moment the dock is drained to the second the ship floats free once again. This is the incredible process of bringing a U.S. aircraft carrier back to life.
The arrival into dry dock. Before an aircraft carrier can be rebuilt, it first has to disappear from the ocean itself. That process begins at some of the largest shipyards in the United States. Places so massive, they look more like industrial cities than naval bases. Tower cranes stretch into the sky, thousands of workers move through narrow steel passageways. Sparks fly from welding stations day and night. And in the middle of it all sits one enormous concrete chamber waiting to receive a nuclear-powered supercarrier.
For ships like the USS George Washington, USS John C. Stennis, or USS Ronald Reagan, the journey into dry dock is one of the most delicate maneuvers in the entire overhaul process. Because despite their enormous size, aircraft carriers have surprisingly little room for error. The dry dock is first flooded until the water level inside matches the surrounding harbor. Only then can tugboats begin slowly guiding the carrier toward the entrance. And when we say slowly, we mean incredibly slowly, sometimes moving only a few feet every minute.
Imagine trying to park a floating city inside a concrete box, with less than a meter of clearance on either side. That is exactly what harbor pilots are dealing with. Massive tugboats push against the hull from multiple directions, constantly adjusting the carrier's position. Crew members monitor alignment using laser systems, markers, and visual references. Every movement is calculated because even the slightest drift could slam the hull into the walls of the dock. And the deeper the ship moves into the chamber, the more intense the operation becomes. Inside the dock, workers wait beside hundreds of massive keel blocks, specially positioned according to a detailed docking plan. These blocks are not randomly placed supports. Each one is carefully aligned with reinforced sections of the ship's hull, designed to carry the immense weight of the carrier. For a Nimitz-class carrier, that means supporting nearly 100,000 tons of steel, machinery, fuel systems, weapons elevators, and nuclear reactors. Once the carrier is perfectly aligned, the dry dock gates are sealed shut. Behind those gates, millions of gallons of water remain trapped inside the chamber. But within hours, powerful pumps begin draining it all away. Slowly, the water level drops. And as the ocean disappears beneath the hull, the carrier begins settling downward, inch by inch. The entire weight of the warship gradually transfers onto the keel blocks below. This moment is extremely dangerous. If the ship settles unevenly, the hull can warp under its own weight. Propeller shafts can misalign. Structural stress can spread across the vessel. That is why engineers monitor every stage of the descent with extreme precision. Sensors track pressure distribution, workers inspect block alignment, teams communicate constantly across the dock.
Hour after hour, the water keeps dropping until eventually something unbelievable happens. One of the most powerful warships on Earth is no longer floating. It is sitting completely exposed, high above the dry dock floor, like a giant steel skyscraper laid on its side. And now, the real work begins. Inside the dry dock overhaul,
Once the carrier settles onto the keel blocks, the entire structure turns into a massive open worksite. Scaffolding covers the hull, and thousands of workers begin rebuilding the ship from the outside in. During a refueling and complex overhaul, the nuclear reactors are carefully defueled and later refueled so the carrier can operate for decades more. Inside the hull, pipes, valves, pumps, and thousands of components are removed and replaced, while propulsion shafts and mechanical systems are inspected for even the smallest wear. On deck, the island structure is upgraded with modern radar, communication, and combat systems. Aircraft launch and recovery equipment is rebuilt and tested, while the hull receives fresh protective coatings to withstand years at sea. The scale is enormous, with thousands of engineers and technicians working at the same time across different levels of the ship. Every system is checked, because even a small failure can affect the entire carrier. If you are proud of the people who build and maintain these giants, take a moment and comment "proud" below.
Preparing for the return to water. After months or even years of reconstruction, the carrier reaches a critical stage where everything shifts from rebuilding to preparation for flotation. Every system is tested again under controlled conditions to ensure nothing fails when the ship becomes buoyant. Engineers run stability calculations repeatedly because the ship is no longer in its original condition. Equipment has been added, removed, and replaced, which changes the center of gravity. Fuel levels, ballast distribution, and onboard weight must be perfectly balanced to prevent any instability during lift off the blocks. The concept of positive metacentric height becomes extremely important here because it determines whether the ship will return to stable floating or risk dangerous tilting during refloat. Side support blocks are positioned along the hull to prevent sideways movement. These do not carry weight, but they act as safety guides when the water begins to rise. Every placement is double-checked against the original docking plan because even a small error can create uneven pressure or structural stress along the hull surface.
Inside the ship, teams inspect every critical system once more. Pumps are tested, electrical systems are energized, and emergency response systems are verified. Communication lines are checked across all departments so that every signal during flooding is clear and immediate. The goal is simple but extremely demanding. Everything must function perfectly before the ocean returns. At this stage, even small details matter, like drainage readiness, valve response timing, and hull pressure distribution. Engineers simulate flooding scenarios to predict how the ship will lift off the keel blocks in real time. And now, the most delicate phase of all is about to begin: the controlled flooding of the dry dock.
Controlled flooding begins. The dry dock is now ready for one of the most carefully controlled operations in naval engineering: the return of water into a chamber that has held a 100,000-ton warship in complete stillness. It begins slowly. Massive intake valves open, and seawater starts flowing back into the dock in precise, measured stages. Engineers do not rush this process because speed is not the priority. Stability is. At first, the water rises only a few feet, reaching the lowest part of the keel blocks. This is the first critical transition point, where the ship begins to feel a change in support, but still rests firmly on its foundation. Sensors track pressure across the entire hull to ensure the load distribution remains even. Divers enter the water to inspect the underside of the carrier. They check for alignment, verify structural integrity, and confirm there are no unexpected shifts or contact points. Every observation is reported instantly to the control team above.
As the water level continues to rise, buoyancy begins to take over, slowly reducing the weight carried by the keel blocks. This transition must be perfectly uniform. If one section lifts earlier than another, it can create dangerous twisting forces across the hull. Inside the ship, engineers monitor real-time data from hundreds of sensors, tracking hull stress, vertical movement, and balance. The entire vessel is in a controlled state of near transition, neither fully grounded nor fully floating. Floating free. As the water level rises higher, the moment of separation begins. The carrier is still inside the dry dock, but it is no longer fully supported by steel blocks. The ocean is now sharing the weight and slowly taking over. The keel blocks begin to lose pressure one by one. As buoyancy increases, the ship lifts with extreme uniformity. Engineers monitor every section of the hull to ensure no side rises faster than the other, because even a small imbalance at this stage could create stress across the entire structure. Inside the control rooms, data streams from hundreds of sensors show real-time movement of the carrier. Hull stress readings, displacement values, and vertical lift measurements are tracked continuously. Every millimeter matters.
Divers report that the gap between the hull and keel blocks is widening evenly across the entire length of the ship. This is the confirmation engineers are waiting for. The lift is stable. Side support blocks still hold their positions, preventing any lateral drift. The dock walls are dangerously close in engineering terms, so precision is everything. There is no room for error when a 100,000-ton structure is moving freely for the first time in months or years. Then finally, it happens. The keel blocks are no longer in contact with the hull. The carrier is fully floating, but it is still trapped inside the dry dock, like a giant contained within a concrete frame. Tests continue immediately. Propulsion systems are checked, power distribution is verified, and navigation systems are brought online. Even though the ship is afloat, it cannot move yet until every system is confirmed operational. After final checks, tugboats are brought into position. Multiple powerful vessels align around the carrier, ready to guide it out. Each tug has a specific role, controlling direction, tension, and stability. Slowly, the dry dock gates open, and the carrier begins its first movement back into the ocean. The slow exit gates fully open. The carrier begins its final transition from controlled enclosure to open water. Tugboats take position on multiple sides of the hull. Their engines strain against the immense mass they are guiding, but the movement remains extremely slow and deliberate. This is not about speed, it is about absolute control. Harbor pilots coordinate every inch of movement, using real-time communication with the bridge and the dock control center. The carrier moves only a few feet at a time, and then pauses for checks before continuing again. As it clears the dock entrance, the scale of the operation becomes even more visible. The ship that once filled the entire chamber is now slowly emerging into open harbor water for the first time since maintenance began. Slowly, the dry dock gates open, and the carrier begins its first movement back into the ocean. Once fully clear of the dry dock, the carrier does not head out to sea immediately. Instead, it moves toward an outfitting berth, a nearby pier where final systems integration continues. Here, the next phase begins. Combat systems are tested while docked, propulsion systems are checked under controlled conditions, and electronics undergo final calibration. The ship is afloat, but still in a transition state between overhaul and full operational readiness. This stage can take months, even after the dramatic rollout has already been completed. But what happens next is what makes this entire process even more important than it appears. Because the United States is facing a growing challenge in maintaining these massive dry dock operations at scale.
Conclusion. When a U.S. aircraft carrier rolls out of dry dock, it is not just a technical milestone. It is the result of years of planning, engineering, and human effort working in perfect coordination. What began as a motionless steel giant resting on keel blocks slowly transforms back into a floating city, capable of launching aircraft, commanding fleets, and projecting power across oceans. Every stage matters, from the precise alignment when entering the dock to the careful placement of support blocks, from months of reconstruction deep inside the hull to the final controlled flooding that brings the ship back to life. Thousands of workers contribute to this process in ways most people never see. Welders inside tight steel compartments, nuclear specialists working under strict protocols, engineers tracking millimeter-level movements during refloat operations, and technicians ensuring every system is restored to full readiness.
And yet the most impressive part is not just the machinery or the scale, it is the precision. A 100,000-ton warship can only return to the water because every calculation, every inspection, and every adjustment is done with absolute accuracy. One error could cost billions. But success means something far greater. It means another decade or more of global deployment for one of the most powerful naval platforms ever created. As the carrier moves out of the dock and into open water, it carries with it the result of millions of man-hours and decades of engineering evolution. Thousands of workers contribute to this process in ways most people never see. Welders inside tight steel compartments, nuclear specialists working under strict protocols, engineers tracking millimeter-level movements during refloat operations, and technicians ensuring every system is restored to full readiness.
And while most of the world only sees the final rollout moment, the real story is everything that happened beneath the surface, inside the dry dock, where a warship was not just repaired, but reborn. If you enjoyed this deep look into naval engineering, make sure to like the video and subscribe for more military breakdowns and engineering stories. And if you are proud of the people who make this possible, comment "proud" one last time.